Welcome to MVCC Learning Commons Math Shorts. The topic in this video will cover the basic rules for exponential expressions. The first rule we will cover is product rule. The expression I have on the left is 6y to the third times 2y to the eighth. Product rule is used when two or more polynomials are being multiplied. This rule has two steps to follow. First, to multiply the coefficients, and second, to add the exponents for similar bases. To begin evaluating this expression, we are first going to multiply the coefficients. 6 is the coefficient in our first term, and 2 is the coefficient in our second term. Multiplying them together, we end up with 12. We check our bases to see if they are the same. Bases are here, they are both y's. Because they are the same, I can now add the exponents. 3 plus 8 gives me 11. So I include a y in my answer. I keep the base, and I add 11 for my exponent. So my final answer is 12y to the 11th. Our next example is using quotient rule. The example on the left is negative 10x to the fifth over 2x. Quotient rule is used when polynomials are divided. Quotient rule also has two steps to follow. First, divide the coefficients and then subtract the exponents. While keeping the base. We begin to evaluate the expression by first dividing the coefficients. Negative 10 is in the numerator and 2 is in the denominator. So after we divide those two numbers, we end up with negative 5. We then look at our variables to see if they are the same. They are both x's, so we can subtract our exponents, keeping the x for our base. We always subtract our exponents starting from the top. So our exponent on top is 5, and our exponent on the bottom is 1, even though there is no number written. So subtracting, we have 5 minus 1, which will give us a final number of 4. So our final answer is negative 5x to the fourth. The next rule is for negative exponents. The expression I have on the left is x to the negative 2 over x squared. Many times the directions for evaluating expressions will require you to leave your final answer with only positive exponents. In order to change a negative exponent of a variable into a positive, you need to switch the location of the variable. The example that is shown here can be done in two different ways. The first way begins by using the quotient rule. Since they both have the same base, we can subtract the exponents. Remember, we start with the exponent in the numerator, so it will be -2 minus 2. And the answer ends up being x, we keep our base, and our exponent is -4. We then need to make the exponent positive, so we need to switch the location of the variable. We begin by making the answer a fraction by putting a 1 underneath it, and then putting the variable in the denominator. This will change the exponent from a negative to a positive, x to the positive 4, and you will end up with a 1 in the numerator. So your answer is 1 over x to the 4th. The second way is to make the exponents positive first. So we see that the variable in the numerator has a negative exponent, so we will move it to the denominator first to make it positive. So this will leave a 1 in the numerator, and then when we switch it to the denominator, both of the variables are multiplied. We have x squared times x squared, which means we use the product rule here to combine the like terms. So we're going to add our exponents and end up with 1 over x to the 4th. The last rule is the power rule. When evaluating an expression with a power, the coefficient is raised to that exponent, and then you multiply the power with the exponent on the variable. For our first example, 6x to the 3rd, all raised to the second power, we will begin first with the coefficient. The 6 is squared because of the exponent. This gives us 36. Next, we work with the variable. The exponent for x to the 3rd is going to be multiplied with our power, which is a 2. We end up with a 6 for our exponent for the x, which is our variable. Our final answer for that one then is 36x to the 6. In our second example, we have 2x over y to the 5th, all raised to the -2 exponent. This is more complicated because of the negative exponent you see here. To make this easier, we can first work with the negative exponent. To make it positive, we are going to reverse the positions of everything inside the parentheses. So everything on top switches position with everything on the bottom. We end up with y to the 5th over 2x raised to the positive 2. We can now use the power rule to finish evaluating our expression. In the numerator, we're going to multiply our exponents, so we end up with y to the 10th. In our denominator, we're going to first square our coefficient, which gives us a 4. And now we multiply the 2 with our exponent on the x, which is a 1 since there is nothing written, which gives us a 2 for an exponent. Keep our base and write our exponent. Since we have squared everything, we no longer have the 2 as a power on the outside, so we can leave off our parentheses. Our final answer here is y to the 10th over 4x squared.